All right, boys and girls, let's do this. Here's what we're going to do. We're going to do this. This is the Pemberton, it's from the Pemberton book, exam number 3. I don't think it's this book. I think it's an older book, but it's one of these. So, anyway, this is what we're doing in class. Let's knock this out. Man. All right. Let's do this. See how we do? We're going to do each one. We'll grade it. I'll put timestamps. I hope. I'll put timestamps so that you can fast forward to whatever question we're going to do. So this is at about 35 seconds right here. So it says Neptune is, 4,496, no, 4,496,000,000 kilometers from the sun. Standard form. That is scientific notation. That's what they call it over there across the sea. All right, so scientific notation, of course, is a single digit followed by a decimal times a power of 10. So this is, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I believe that's right if I counted correctly. We'll find out here in just a minute. Okay. Problema numero dos is going to be at 117. All right. I have to work this out and give my answer in standard form. Now, this is kind of interesting because when I look down here, this is a paper 2 question. However, in England, and this is the British one, they can use a calculator. So this 240 right here squared. Well, I don't know. I mean, I guess I could do it, maybe try it without a calculator. Let's see here. Let's see, 240 divided by 5. Well, that's going to be 48 squared. Now, I'm going to use my calculator. I don't want to make a silly mistake with the order of operations, so I'm going to use this one. Now, normally, if this was an American paper too, you wouldn't be able to use your calculator. Okay, so divided by 5 times 10 to the power of 6. Now, the thing is, you put some parentheses in here, so that is 0.01152. So that is 1.152 times 10 to the negative 2, right? 1, 2. Yeah, negative 2. I think. I hope I counted right. Oh, no, we're doing this from scratch. I would be surprised if I get 100 on this. I don't know. We're going to grade it at the end. See how I do. All right. So now we're at 240. Let's do number 3. In standard form, so this is pretty straightforward. 2386 times 10 to the power of 3, 6, 7, I think. Yeah, okay. Now calculate this, give your answer in standard form. Now, the problems that we see on our syllabus, which is syllabus 0444, they'll all reduce easily by hand, okay? But again, this one is written for England, and they get to use a calculator, so their numbers don't work out as clean. All right, so I'm going to use my parentheses. Oops. So divided by 100. All right, so the 0.23. I'm going to stop right there. So that's going to be 2.34, and that is rounded to 3 significant figures, times 10 to the negative 2. I think that's correct again. We'll find out. I'll probably be grossly embarrassed with some of these dumb mistakes I feel like I'm making. All right, so 355. All right. Calculate this. Once again, give your answer in standard form. Now, this one actually is a little tricky. Check this out. This is multiplying, so I'm only going to multiply that by 1. That. Yeah. So like this right here, this is actually the same as 2 times 3 times 4. And you notice when you multiply 2 times 3 times 4, the answer is 24. You just multiply 2 times 1 or the other. You don't do it by both. And that's, oops, sorry, I hit my camera there. That's exactly how this is. You either multiply the 5 times the 6 or the 5 times the 1,000. So I'm going to do 30 times 10 to the third plus, I think that's 2,000, right? 5 times 400 is 2,000. Okay. And then, so this is 30,000 plus 2,000. That's 32,000 1,000. So that's going to be 3.2 times 10 to the 4. I think that's correct. Hey, let's go ahead and grade this first page since we're at it right here. So for number 1, let's see, 4.496 times 10 to the power of 10. We are good there. Number 2, 1.52 times 10 to the power of negative 2. We are good there. Let's see here. Number 3, 2.386 times 10 to the power of 7. Man, I was not feeling confident with this because normally it's like stuff like this where I make mistakes. It makes me upset. But anyway, 2.34 10 to the negative 2. And then the last one, of course, I jinxed myself. It says 3.2 times 10 to the power of 11. Hold on, let me see what kind of stupid thing I did right here. What did I do wrong? Number 4, part A. It says 3. Number 4, part A. 3 times 10 to the 11. Well, this is kind of strange. Oh, there's something wrong here. Because it says 4A and 5, and then 4A and B, and there's no 5. So, let me run through this question again, because I don't. There's no 4B. It goes to 5. Huh? There's something kind of screwy right here. I'm kind of curious if this is actually correct. Let me look at this again. Let's just try this again real quick. Double check. Okay, I'm gonna do it on the calculator now. Okay, so 6, times 10 to the 3rd, plus 400. Okay, and then multiply that times 5, 32. Yeah, so this is correct. There's something wrong with that answer document. I'm not sure what it is, but that's okay. So we're good to go on the first page. Man, look at that hotness right there. Okay, so next one, we're at 7 minutes 10 seconds. Oh, man, this is great. All right, 7 minutes, 10 seconds. Okay. So there are 10 to the 9th nanoseconds in 1 second. So a nanoseconds really small. It's a billionth of a second, I guess, right? Find the number of nanoseconds in 5 minutes. Give your answer in standard form. Well, it looks like we have to figure out, well, how many seconds are there in that many minutes? So there's 60 in 1 minute. So times 5, well, that would be 300, right? And then 300 times 10 to the 9th. So that would be 3.0 times 10 squared times 10 to the 9th. So that would be 3 times 10 to the 11th. Yeah. So here, watch, check this out. This right here should say number 5. So there's actually no answer here for number 4. So there's a mistake on that. All right, interesting. Okay. Next up, Buttercup says solve the equation. Oh, this is interesting to do because the x is inside of the parentheses. So we have a couple of options we could do here. We could distribute and say 5x plus 15 times 10 to the 6th equals that. Or we could divide because 40 times 10 to the 6th would be the same as this, and you divide that by 5. So I think I'm going to do that. It's going to give me 8 times 10 to the 6th. See, 4 times 10 to the 7th is the same as 40 times 10 to the 6th. And the reason I did that is because I wanted to reduce it by 5. And I get that. Now, look, I'm going to just show you on my calculator, right? 4 times 10 to the power of 7 equals, and then if I divide that by 5, I get 8 to the power of 6. 1, 2, 3, 4, 5, 6. See? Worked. All right. So now, that worked out nice. I'm glad I did it this way because I'm going to subtract this from the other side. There we go. We have 8 of something minus 8 of something minus 3 of the same thing. So that gives us 5 of that thing. So this would be 5 times 10 to the 6. Now, it doesn't say give it in standard form, so it would be the same as this. 5 million. Either way, we're all good. Okay, numero 6 says 9:43. That's how their time. 43. Okay. Number 6 says on a light on a computer comes on for that amount of time. That's how long a nanosecond is. Oh, microsecond. That's how long a microsecond is. I had nanoseconds in my head from before. Man, got to read carefully. Work out the length of time in seconds that the light is on. So this is a ratio question. Standard form, once again, scientific notation. This is written out, probably correct to 3 significant figures. So here's what we've got. We've got seconds to microseconds is 1 to 10 to the negative 6. Okay, right? That's from this right here. Okay, now, this is microseconds. We have to figure out how many seconds that is. So we're going to multiply 26,700 divided by 10 to the negative 6. And I have, whoa, really small number there. Hold on, I don't believe that that's correct. I'm not really sure about this. I think the number's right, 2.67, of course, right? Oh, yeah, okay. Oh, you know what I did? Okay, that's how, I'm sorry, hold on. Sorry, I'm thinking out loud. This is the problem with doing things like this without reviewing, but I just kind of want to share with you where my confusion is. All right, so let me back up. Let me explain what I messed up right here, and hopefully you can learn from my mistakes. So check this out. Here's what I did. I didn't calculate the number of seconds. I got this upside down. I got this upside down right here. This is backwards. You see, 1 microsecond, and I have 1 second. So I have this upside down. I made a mistake. This is seconds to microseconds. So it should be 10.10. Sorry, 10 to the negative 6 seconds over 1 equals x over. There we go. Now we're talking. So I had my ratio upside down. So in standard form, 2.67 times 10 to the negative 2, or 0.0267. All right, so let me back up. Let me share with you what I did wrong. I had my ratio backwards. And the reason I had my ratio backwards, I didn't read this correctly. So 1 microsecond, and I had this backwards. Look, I had 1 second is that many microseconds. That's what I wrote here. This is totally backwards. So I messed that part up right there. All right, no big deal. Fixed it. And the reason I felt like I got it wrong, excuse me, the reason I felt like I got it wrong is because I had a really, really small number on my calculator. I didn't expect us to write a decimal with, like, I don't know, 12 zeros or something in front of it. All right, number 7. Now we're getting into some algebra stuff right here. 1322. Okay, so solve the simultaneous equations. All right, there's 3 ways we can do it. Graphically, substitution, elimination. I think I'd do this one with elimination, because if I multiply the second one by 6, then I can just combine them. Got some arithmetic to do here. So I'm going to multiply the second one by 6, because it makes the y's the same. There we go. So that's 9 equals 18x. So x is 1/2, right? So if x is 1/2, 2 times 1/2 minus 3y equals negative 8. So that's 1, right? Negative 3y equals negative 9. Then 1/2 and 3. 1/2 and 3. Okay, let's grade this one, right? Let's grade this page. Here we go. So let's see, number 5, which we already looked at, was really on this, was number 4. They have a typo, so then they skipped that one. They skipped number 4, so that's good. That one's good. And so this one I got right, and this one we got right. So we're good on both of those. We're good on this, and we're good on this. Next one, I've got 2.67 to the negative 2. And then the equivalent of that, 2.67 times 10 to the negative 2, and then the decimal equivalent, so we're good there. And the last one is 0.5 and 3, 1/2 and 3, we're good to go. Man, killing it. Okay, next page. Let's see, we are on 15 minutes and 5 seconds, más o menos. So solve this set of equations right here. Let's see here. This one, I might want to do substitution because I would have to multiply both equations by something and one of them by something negative. Man, I can multiply everything by 10. So, and then, let's see here. Okay, well, man, I'm spending a bunch of time trying to figure out what is the way that I could do this that's going to be the easiest. The reason I said multiply everything by 10 is that I could set this up as a fraction. It's 4/10 and 3/10. Or I could multiply everything by 10 and then the fractions go away. Watch. I do end up with some slightly larger numbers, but they're, a multiple of 10, so it's not a big deal. So I could start it that way, and then, I could make these in the same, and, so I could multiply this by -3 and this one by +4, for example, if I wished. Let's go ahead and, let's go ahead and do that. We'll do elimination in the next one. So let's multiply this one by -3, this one by 4. So what we're going to get, -12x minus 60y equals -300. Let me make sure with that. -12x minus 60y, -300. Good. And then +12x plus 200y equals, let's see, 32. Well, let's see. I got my calculator. I shouldn't have to do this in my calculator, but I'm going to 720. All right, so let's add these up now. Look, those go away. This is positive 140y equals 420. I'm going to guess that 420 divided by 140 is an even number, 3, duh. Yep. So y is 3. Since y is 3, we just got to plug it into one of our originals. I'm going to plug it in to this one right here. Let's do 4x plus 60, because remember y is 3 equals 100. So x is going to be 10, because you're going to subtract, right? 10. So 10 and 3. Okay, good to go. All right, next up. This one I'm going to use elimination because I have a coefficient of 1 for that. So x is going to be 18 minus 2y. I'm going to solve, right? I'm going to move those to the other side. And so I'm going to do 3 times 18 minus 2y. Notice I put the negative second just because it fits better. Minus 4y, and I'm going to go ahead and move the 4 to the other side so that it equals 4. So 54 minus 6y minus 4y equals 4. So 10y equals -50, so y is -5. Since y is -5, I can plug that in right there. X equals 18 minus 10, 8. 8 and -5. Let me make sure. Yeah, no, I think that's right. -5. All right, let's move on, and we'll grade it in a second. Okay, now this last one's kind of ugly. Well, actually, you know what? This one's not so bad. Watch. 2x plus y equals 14. 2x minus y equals 34. You see what I did? I just multiplied out both sides by 2. I multiplied both sides by 2, and I ended up with this. So now I can combine those equals 48, so x is 12. All right, if x is 12, I'll put 12 right there. That's going to give me 24 plus y equals 14. That would mean y have to be -10. Let's see here, -10. All right, let's grade this. All right, let's see here. Let's see here. I forgot to write down timestamps for those ones, but that's okay. So let's start off with number 8. Number 8 says 10 and 3. 10 and 3, that's good. Number 9, see, I got 10 and 3 right here. 10 and 3. Number 9, I got 8, -5. But number 9 says 8, +5. Let's see, 8 positive. Let's see. We already had a typo on this. Let's see if we got this one right. Let's because here I've got clearly -5. So, oh, it is +5. I think I made 2 sign errors. They cancel each other. Check this out. Here's the deal. That's -10 right here. This is -10. I was going too fast. I subtracted. That's all good. Y is 5. I did. I made a double. I made a double mistake. I plugged in positive 5 right here. So check that out. Sometimes sign errors do that. They like you make a sign error twice, it kind of undoes itself. That's what I did right there. So that's a sad story. I missed one there. Somehow or another, I still got the other one right. All right. Oh, sorry, you couldn't see what I was talking about. Here, let me show you. I apologize. Look, here's what I did. I had a positive right here, and then so and it should have been a negative because it's -6 and -4. So I messed that up. And then when I plugged it in, I actually plugged in a positive 5. I didn't plug in -5, even though I had written down -5. So, man, sad story. All right. Let's see. For the last one, I got 12, -10, and 12, -10 is what the thing says right here. So let's move on to number 11. And let's see. The time is 20 minutes, 45 seconds. All right. Factor. Ooh, what the factor? So I've got a factor of y on both and a factor of 2. So I can take out 2y and I get 3x minus z. So that would give me 6xy, and this would give me -2yz. So there's my answer. 2y, 3x minus z. All right, for number 12, number 12, 21, 13. All right. Make x the subject. So that just means solve for x. So on this one, we have to subtract 7 from both sides, and then we're going to multiply both sides by 2. Show your work. That way, if you make a silly mistake, you're going to get some partial credit. 2y minus 14 is what x equals. It already has x equals there for me, so I don't need to do that. Make d the subject of this formula. So let's see here. This one is at 2141. Make d the subject. So I have to get this thing by itself, so I got to get rid of the denominator first. So then I'm going to subtract. Then I'm going to divide both sides by 5. So here's what I got. 2wc minus 4w divided by 5. Boom, done. All right, let's check this one very quickly. Más rápido. So number 11. Let's see. The thing says 2y, 3x minus z. 2y, 3x minus z. Cool. For the next one, I got 2y minus 14, and it says 2y minus 14. The last one says 2cw minus 4w divided by 5. I have WC, CW, same thing. That's a little better, CW, because it's in descending order, but same thing, we're good to go. Oops, sorry here. Let's see here, 2240 for number 14. 2240. All right. Ooh. Rearrange the formula to make y the subject. So I have to get the x on the other side, the 9 on the other side. So I'll go ahead and show my work, right? And then I multiply both sides by 9. Now I could leave it like this if I wanted. Either way, I could do it like this. Either way, oh man, I'm gonna square both sides now. So now that I see that, I think that my first one is better. So I got 9 minus 9x squared. So I don't know if that is an acceptable answer or not. I don't know if this is acceptable or not. I don't know if they actually want us to square it, which would be out of descending order. It would be that. I think. I don't know. I don't know what they want us to do. I think this is probably okay. You could square it. Either way, show your work. All right, number 15. All right, so we're going to get into some geometry now. Some of this geometry stuff can be a little tricky. So 2355 about. So describe fully the single transformation that maps A onto B. Okay, got my straight edge here. So this is a reflection. The reason I believe this is a reflection is you see how the orientation is flipped over? Do you see what I'm talking about? Like if you just rotated this, this little part is going to be pointing down. So like you see that part right there? But here it's pointing up. And I think this is a reflection. So I think it's a reflection over the line y equals x. 2 points, one for naming it, one for naming the line of reflection. So I believe that's right. Yeah, so look, I got 1, 2. I got 1, 2. It's perpendicular. These are like, yeah, we're good. Okay. So let's see. On the grid, draw the image of A after a rotation of 90 degrees clockwise about the point 4 comma 4. Oh, so that's right here. Oh, so it's actually, that's interesting. If you thought, this is kind of cool. If you thought this first one right here was a rotation, you're going to see that it's not here when you do the second. That's kind of cool. So we're going to rotate that 90 degrees. So I believe, let's see here. Oh man, 90 degrees. So it's going to look like this, right? Do you see it's going to look like that? Okay, rotation of 90 degrees. Well, let's see here. This is 1, 2, 1, 2. So that point's right here. So it's going to look like this, I think. Now I'm pretty sure when they grade it, they're going to have us look at some of those points right here. This is 4, 2, and this is 4, 3. So I'm not entirely confident on that one. I haven't done reflections for a very, very long time. But let's go ahead and grade it and see how we did, okay? So number 14. Number 14 says, okay, all right, so they were okay with leaving it factored like that, which is fine, which I kind of suspected. Number 15 says, let's see, I have reflection over y equals x, reflection over y equals x. And then for 15b, oh my gosh, I got it wrong, and I know exactly what I did wrong. Oh, do you guys know what I did wrong right there? I did 270 or 90 counterclockwise. Oh my goodness. Oh, that's terrible. I hate when I do that. I wasn't really paying attention to what it said. Look, right here. It said 90 degrees. 90 degrees now. I should have, like, I even when I did it, I said I wasn't feeling very confident. Man, I should have caught that. I did 270 or 90 degrees the opposite, because I was so focused on this, and I was thinking, I don't know. I was thinking that they're going to kind of double up on that stuff for us there. Oh well, sad story. Maybe my mom's right about me. Maybe I am worthless. All right, 2715. My mother never said that, at least not to my face. She's a very nice lady. All right, number 16. Let's do this, number 16, shall we? So number 16 says, write down all of the letters of the triangles which are congruent to the shaded shape. So congruent is means it's the same size and everything like that. So I think we have E. I think we have G. And I think that's it, because this is 1, 2, let's see. It's 1, 2, 3, 4, base of 4. 1, 2, 3, 4, good. And then this long side, and then 2 and 2 and 2. So yeah, I think that's it, E and G. I don't think any of the others are congruent. Okay, now, similar but not congruent. So similar means that it's proportional. So like this was a side of 4, so it would be like, 8 if that was double size, and if that was 8, this would be 4. So let's take a look. So this is 2 and 1. This was, let me just double check. 1, 2, 3, 4. This is 4 and 2. This is 2 and 1. So A works. A is similar. 1, 2, 3, 4, 5. Nope. This looks 2 and no, and 1, 2, 3, nope. So 1, 2, 3, 4, 5, 6, 7, and 3, nope. Let's see, 1, 2, 3, 4, 5, 8, and 1, 2, 3, 4. Okay, B. Let's see what D's up to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3. Nope. So I think it's just A and B. Okay. Let's check this one now. Let's see here. GE, got that, EG, and AB. So we are good to go there. All right, next up, Buttercup. Let's do number 17. Okay, let's start number 17. I already did it. Stopped the video. I messed it up. I did it in pen. I wasn't really reading very, very well. And anyway, so now this isn't an authentic recreation of my thinking, because I already messed it up once. And so now I'm going to go back and fix it. So I'm going to make my grid 6 by 6, just like it says to. Let's see here. So let's see, that's on 1. Let's see here. There's 1, 2, 3, 4, 5, and 6. That's 6. All right, let's see. Let's go this way. Let's go this way. All right, so there's -1, -2, -3, -4, -5, and -6. All right, let's go up. I'll start this way. So 6, 5, 4, 3, 2, and of course 1. And it turns out for this one, we don't even need to go to the negatives, but we're going to do it anyway. 1, 2, 3, 4, 5, and we didn't even make it 6. All right, so now that's 17 part A. That's actually worth 1 point, making that correctly. Next part would be draw a, and this was actually on a test, so they actually graded that. So your ability to do that correctly, muy importante. So draw ABC, 2, 1. 2, 1. That's A. 3, 3. That's B. And C is 5, 1. 5, 1. C. Let's connect those dots, make that triangle right there, all nice and pretty, just like all of you. There's ABC. Okay. Now, no problems there. That should be a free 2 points, I think. Okay, now part C, which is worth 2 points in and of itself, says draw the reflection of ABC across the line y equals x. Okay, well, since that's 3, 3, I know that's on my line y equals x, and it's going to go right through the origin. So, yeah, I just got to reflect it, so I'm going to go straight across. So that's going to be A1. And let's see, this is 5, 1, so it's going to be... it's 5, 1, so it's going to be at 1, 5. So let's go ahead and do that one right there at 1, 5. It's right here. So that's C1. So here's what our triangle is going to look like. So it's kind of a hand-drawn thing. It should actually end up being a straight line in reality if I had a real graph. But there we go. So there's my reflection over the line y equals x. And if you folded this one, you can kind of see that it would line up nice. All right. Next up says rotate my second triangle. And this is what I messed up on when I just did this right now. I did the original. So rotate the second triangle about the origin 90 degrees to the left, so counterclockwise, and then label it A2, B2, C2. So the way I like to do this is I like to rotate it and then see what it looks like. So look, C is going to be on the left of A and B is going to be above. Do you see? I just rotated it 90 degrees manually, and it's going to look like that. Okay. So how's that going to work? So see how this is 2, 1? 2, 2, 1. 1, comma 2. So I'm going to switch that around. It's going to be right here. It's going to be -2, 1. It's going to be right there. 90 degrees. See, 90 degrees. That's going to be a 90-degree rotation counterclockwise. So that's going to be A2. All right. Now let's see here, just to make sure. So yeah, C is going to be right across. So C is going to be, let's see, that's a distance of, what is that a distance of? From 2 to 5, that's a distance of 3. So 1, 2, 3. So it's going to be over here. This is going to be C2. All right. And I could do the same thing. Like I could go like C, make my 90-degree vectors and connect them like that. And that, if I had a pencil in hand, which you can't see very well on this kind of a diagram, whoa. And you should do these in pencil. And this was actually on a grid. You could actually see that a little more easily, but just kind of eyeballed it and see how it went. Now, I know C is above, right? C is above A. Like this C right here is going to be, this B is going to be above. So it's going to look like this right here, you see? So it looks like left and up. Left 2, left 1 up. Left 1, and then up 2. Left 1, up. Right here. There's B2. All right. So that's what this is going to look like right here. So I don't actually, usually, I don't do a rotation for every point. The only time I use every point usually is if I'm doing a dilation or an enlargement. But usually for rotations and reflections and things like that, I just find 1 point and then figure out the relationship, the distances between that 1 point and the rest. So anyway, here we go. Next up says, so that's, we just did part D. Yes. Describe fully the single transformation that maps ABC onto A2, B2, C2. So, You see how it's flipped over? I think that's a reflection over x equals 0, the y-axis. I think that's what it is. I think it's a reflection over the y-axis. All right. Number 18. Man, if you guys are like me, you haven't done these geometry things for a while, and they're probably challenging you to think, and you probably don't have a lot of confidence, which is exactly what we need. We need to be challenged, and we need to develop our confidence through experience. So, draw the reflection. Let's see, what time? Oh, well, draw the reflection of shape A in the x-axis. Draw it. So, over the x-axis. So, here's the x-axis. So, that's a distance of 1, 2, 3, 4. So, 1, 2, 3, 4. So, it's going to be right there, right here, and right here. So, this would be the reflection of A. It's going to look just like that. So, let me go ahead and draw that real quick. And label it B. So, there's B. Okay, now rotate B 180 degrees about the origin. So rotating it all the way over here. So it's going to be 180 degrees. So it's going to be flipped over and around. So it's going to look like that right there in the second quadrant. So it's going to be all the way up there in the second quadrant, 180 degrees. So one way you can do this is 180 degrees right through there. So let's see, this is at 2, -4. So it's going to be right here. You see I got my line lined up right there. That's going to be this point right here. And yeah, so it's going to look like this. Base of 4, right? And then let's see here. I'm going to see if I can do it visually. So then one spot away from the corner over here. Right there. That's a distance of 1. So let me double check that real quick. I don't know if my straight edge is long. Yeah, it's long enough. So this is the first corner. Yeah, we're good. All right. Let's just check. The rotation of 180 kind of makes a straight line, so that's kind of nice. And so label that C. Okay. All right. Now, describe fully the single transformation that maps C onto A. So this onto that. Well, that's kind of the same question as the last one. That's a reflection over the y-axis, which is the same as x equals 0. All right. Now, let's see. Last one for part 18, number 18. Draw an enlargement of A. Scale factor 1/2. Okay, so here's how you do this, right? You draw all your vectors, all your lines, to the center of enlargement. 1/2. That means that the distance, like, see the distance from here to here was over 2 and up 4. So now it's going to be over 1 and up 2. So you see this point's going to be right there. Do you see? And this point's going to be right here, right? Because it cuts it in half. And then from there we can kind of figure out the rest. Let's see, that was a vertical distance of 2. So now it's a vertical distance of 1. So they're going to be right here. So if this was, I should have really done this in pencil, but I wanted to make sure you guys can see it. So I'll shade it in here, okay? But, even though it didn't say shade it in, but I shaded it in right there so you can see what that looks like. All right, last one, number 19 says a cylinder has a height of 14 centimeters, and a volume of 850 cubic centimeters. Calculate the radius. The radius, so that's the volume formula, pi r squared h. So 850 is our volume. We have to figure out the radius, and we know the height is 14. So we're going to use a calculator on this one because it's a paper. Well, it's cut off, but so here's what we're going to do. I'm going to solve this. I'm going to divide by 14 pi, right? And then I'm going to take the square root, and that's r. So whatever that turns out to be. I got to use my calculator correctly, though. So let's see here. 850 divided by 14 pi equals 19.3. So second square root of my answer, 4.40. Correct to 3 significant figures. All right, let's grade these last parts here, shall we? Let's see how we did. Okay, so for, let's see here. Let's see, how we doing? Okay, here's 17. So that's the original. This is the original right here, so I got that. Right, so here, I got that. That's fine, that's no problem. I can count my coordinates right there. That's the reflection up here, so we're good there. And then that looks correct as well. So the points would be negative 5, 1, negative 5, 1. You see, negative 5, 1, and negative 2, 1, and negative 3, 3. Negative 3, 3. So we're all good. We're good there. Reflection about the y-axis. That's what it says right here. So we're good. All right. So now number 18 says, all right, so here's A. That's no problem. A's no problem. This is correct. This is correct. And that's correct. So we're good there. Reflection over the y-axis. That's what I've got for the set part right here. Reflection over the y-axis. And then 4.40, correct to 3 significant figures. 4.40, correct to 3 significant figures. Man, that one took a while. Took a long time. So that means it's probably going to take you a while. Now the geometry stuff kind of messed me up. Significant figures kind of messed, or no. Scientific notation at the beginning kind of messed me up. Man, we got to be careful with those things. Anyway, this is great practice. You guys are doing a good job. If you're watching these videos and checking your work and learning from it, man, you guys A stars in your futures, bruh. All right. You guys have a great day. I'll talk to you soon.